Good morning, engineering 2. Woo. Let's talk about the lecture assembly drawings. Okay, so up to now, what you guys have done are parts. Simple part. All of your drawings having parts. So I want to work tonight. Up to now, you guys have done I don't know, simple parts. Maybe a square. Okay, but you most likely will be really hard for you to actually make something move or something function that it has your intent in only a single part. So most likely you will have a combination of parts that have been put together to actually make a function. Let's say you guys want to look at a car, right? Let's say a car right there, another car, right? Within your car, you have a wheel. And again, the wheel will contain an assembly in itself. Like, I don't know if you guys ever look at a wheel using the tire itself. The tire itself is composed of many layers, right? And within the layer, within that, you have your rims. You also might have brake pads, a bunch of screws, a bunch of nuts. You also have a motor, and that motor contains like, I don't know, like 700 parts. You have your transmission, you have your radiator. I mean, there is way too many parts. We can call this guy an assembly. We can call this guy an assembly. We can call the wheel an assembly. All of these together is also an assembly. Okay. Maybe as you were making your model, maybe in here you have, I don't know, a single part. Let's call this a glass. Okay. And you will buy the glass separately, and then you will install it, or let's call it a simple part that you can actually put there. Maybe you just have a couple of a special bolt that needs to be put there, right? Let's call this like a bolt. Okay. Well, I gotta distinguish between this assembly and this assembly. This is an assembly, this is an assembly, this is an assembly. Maybe in your, I don't know, in your radiator, you have an assembly within that assembly. Okay. So let's say radiator here. And that's my radiator. Like that. And it's maybe somewhere inside. Let's call it radiator. Let's call it transmission. Transmission. And then I want to take away this guy is the motor. And let's call this guy the transmission. Okay. Let's take that within the transmission, you have another assembly. Okay, so it's kind of like building up on itself. So within the transmission, you have an assembly that is going to go into this assembly. And also in this assembly, you may also have some parts. Okay, so I gotta distinguish between types of assemblies. How am I gonna call this? Okay, so I'm gonna call this guy, the big one, the one that contains my whole car, I'm gonna call it high level assembly. Okay, think of it like the papa or like the grandpa. Within my high level assembly, the other assemblies that are part of the high level assembly, I'm gonna call it low level assembly. Low level assembly. Okay, and the way you will call out this, if you want to have a drawing, which by the way, we're going to have a drawing, similar, like, I mean, not as complex as car, but will follow similar things. So for example, like right there, you have a high level assembly that is composed of parts and low level assembly parts. Within the low level assembly, you can have children assembly. This is a low level assembly as well. We don't do low level assembly. And again, between this transmission, you can also have a bunch of bolts and nuts and washers. So an assembly drawing depicts the assembled relationship of two or more parts, a combination of parts and subordinate assemblies or low-level assemblies, and a group of assemblies requires to form an assembly of high order or the high-level assembly. So within your high-level assembly, you might have low-level assemblies and also parts. In order to become an assembly, you need to have at least two parts or more. The drawing should contain sufficient views that show the relationship between each subordinate assembly and part. The way you will call out this, a different type of assembly, the way you will call it, you will have a bubble. See, it's a bunch of bubbles. Bubble. Within those bubbles, there will be a number. Within that number, you will have a bill of material for a part list. Okay, so on the left side, what you can see here, this guy, is where you want to have the bubbles. And right next to it, you will have most likely like a description. And then most likely on the right side, you will have the quantity. And then somewhere on the right side, you might have the part number. So when you go and you start making assemblies, and again, you guys will create your simple assemblies, but understanding how to make a assembly will give you the tools to do other type more complex assemblies. So, for example, you go and you have your car. Let's go the car, right? So that car has a subassembly or a low-level assembly or subordinate assembly. I'm going to come and I'm going to make a list. And in here, I'm going to put a bubble. Bubble 1, bubble 2, bubble 3, bubble 4, bubble 5, 1, 2, 3, 4. You continue putting bubbles all over the place, and you will put it here 2, 3, 4, 5. You will have again a description. You will have the quantity. Maybe some of these parts you already buy them as is. So you're gonna call out. Maybe you got it from Mastercard or wherever you got it from, right? A little bit more description. For the parts that you actually get to produce in the shop, you gotta give it a part number. Part number. So you can call it PS33128, something that describes the part. And then when you actually get to produce the drawings, you're going to have different type of drawings. One of them is going to be your high-level assembly. And then you're going to have drawings of subordinate assemblies. And then you might also have drawings of each of the part numbers, right? Each of the parts that you call out. So if you have 20 parts, you will have 20 different parts drawings. You might also will have a sub-assembly that is calling out to the parts that live within the sub-assembly. Again, remember, subassembly is the low-level assembly, like your transmission or like your motor or something that's a little bit more complex. Otherwise, if you guys were to put everything in one assembly, I just imagine a car, this list that you guys see there, it will be infinite, right? Will be infinite, too many parts, everything all put together. And it also will be super hard to actually show every single part because the transmission in itself, it's a jungle. So you'll subdivide it and divide and conquer. It's called divide and conquer. Okay, so what do I write here? So again, I think I just told you, think about the high-level assembly as the papa. Think about the subordinate or low-level assembly as the children. And the parts is something that gets to be kind of added within the subordinate or the high level. Okay. There are different types of assemblies. There is not only one type, and there is not a specific standard for assembly drawings. It's not like the ASME Y14.5 gives you specific standards of how you should present the drawings, because different users will use the assemblies for different things. For example, if you guys were to be in a welding shop or the manufacturing department and you need to put something together, you require how things are going to be assembled together. Maybe you have a plate, so the welding department will go and grab the plate, say, okay, I have a part, maybe my assembly is something simple like this, maybe like that, right? Just two plates put together. Say, okay, you know what? I call it in my bubbles, and this bubble is called part 1, this bubble is part 2. I have my bill of materials, right? Bill of materials somewhere in there, part 1, part 2, and I gotta give it a number. Let's call it part 001 and part 002. Okay. So when the welding department comes, he's gonna look at your drawing, and the drawing is gonna look like this. Okay. So he doesn't really need to know what is your part, and if he's gonna give it to you, you can give it to them as reference. But what they really need to know is how they are going to assemble and what type of welding they are going to be calling out. Okay? Because that's what they're going to do. So you can call out the bubble, there. They will go to the individual drawing, and that individual drawing will tell them what is the size of this plate, what is the size of that plate. And for the welders, the only thing that they need is to know where this plate is going to live at and what is going to be the tolerance. So when you have an assembly, you are not necessarily required to put dimensions for the parts themselves because the parts will have their own specific drawings on the side. What you gotta put on the assembly drawings is information necessary for them to be able to assemble or to, in this case, to weld things together. What about if you were to be a buyer and the only thing you need, maybe you have a water pump, or maybe you have a certain kind of equipment that you are going to use it for a high-level assembly. Let's think about, maybe you have a new design that you are going to use a motor somehow, and that motor that you want to buy, the only thing that you need is the overall size of a motor. I want to know the overall size because I want to put it in a new car that I'm building. And this is my hood on my building that I'm building, and it looks like this. And here's the car, like that. The only thing that I need is to know the overall size because I am going to stick it in there. I also need to know the anchorage points because I have a chassis, a frame where I want to be bolting this, so I want to have a couple of bolts, and I need to know where the location of these guys are or I'm going to have to do some certain type of machining to this to be able to adapt it to it. I don't really need to know if you have pistons or where they are located, what kind of washers are inside my motor. I buy this guy as, and me as the user, as the one that bought this motor, all I care is about my horsepower, location of bolts, overall sizes, and boom, done. If I'm part of the maintenance department and I maybe something broke down and I need to get one of the parts and replace them, well, what I might need is I might need an exploded assembly to see what the part that I need and how am I going to assemble it together. So for different users, there will be different. There might be different assemblies that can be useful. That will contain different information, but there is not a single standard of how to prepare assemble drawings. As long as you can follow any of these guys, and again, also if you guys get to work on something like this when you guys graduate, or when you guys find a part-time, or when you guys get an internship, you guys will find out that many times what you gotta do is just follow the company's standards. The standards of the company will tell you, hey, you gotta do it like this, you gotta do it like that. This is how we've been doing it for many years, and so forth. Okay, now that we know these are the types of assembly, we got general assembly, which is the one that is similar to the one that I just show you. You also have a detailed assembly, sometimes also called the working assembly, which is more like the general and the detailed assembly are kind of a little bit similar. The detailed assembly, let's call it, is kind of like a low level. In separate assembly, that's the manufacturing assembly, the one that you tell them how to assemble things together. You call it inseparable because you put things together with welds. Installation assembly is how you want to install something, put things together. Remember, assembly is to put two or more parts together. Outline and exploded assembly. Exploded assembly is when that's for the manufacturing department. That explodes things and separates it apart so you can see. That's the part that I need. Okay, let's talk about one of them at a time. The only thing that I wanted to tell you here is that there are different types of assemblies, and depending on different users, each of them will have different needs, therefore a different level of information. Okay, general assembly. Let's start with the first one, which is the easiest one, which is the one that I kind of already talked about. So, the general assembly shows the various parts of the product and how they fit together. Okay. For example, in here it seems to me that I have a pulley, and within the pulley I have one, two, how many parts? I got 6 parts. And the 6 parts, it seems to me, it also includes a pin that is threaded on both ends. And in the middle, it seems to me that it has kind of like a bearing, like a roll bearing. So you will call out each of the components that are there, but at the same time, you also need to give them dimensions such that they can assemble it together. For example, if I were to look at this assembly, and again, these are the bubbles that I was telling you guys. If you guys were to look at this assembly, in order for me to see what's inside this pulley and the pin, I need to actually section that view. For example, once I take this section, I look at it and I can see things inside of it. I need to show them how they're going to build it, how the assembly condition is going to go. Not necessarily dimensions of the parts themselves. So I won't go in and start dimensioning the size of the pulley and the diameter, none of that stuff. And if I were to give it to them, it's meant to be as a reference so they know. Okay. However, in terms of assembly condition, if I were to have something like this, I most likely will want to give them the diameter of that pin, but because there is already a drawing for that pin, that's why you have a bubble. You are going to call this, and you can give it a reference dimension so they know. You can also might come over here and go and give it the reference dimension of the reference dimension of the pulley. I think that's all I'm going to give them. Now, in terms of assembly, I want to give them this dimension because I want them to know what distance should be between my pin that I'm placing and my pulley to assemble things together, right? I want to put that. Now, this guy is not to have no reference dimension because it's an assembly condition. While the other ones, they are just so you know, when you go and you try to look for my pulley part somewhere in the shop, you want to know what is the diameter, double check that everything that you grab the right piece. Let's go continue with the general assembly. The individual parts on a general assembly are not dimensioned. The only dimensions that maybe appear are those that are important to the assemble condition, such as the overall assemble size. So, if you get to give it any dimension, maybe you will give it to them as reference dimension. And any dimension that is there that you will give them without references is because it's going to be part of the assemble condition. Instructions for them to put things together. So let's take a look at the part list a little bit more into detail. This is one of the part lists, is the same drawing that you guys had before. And here is the bubble numbers 1, 2, 3, 4, 5, 6. So it seems to me that it has 4 parts. You will have a part name or a description. You are going to have a part number. Remember, you will have a drawing for each of these parts. And you also need to let them know how much they need. Maybe in my part, it looks like this, something like that. And within it, I have a bolt. Right? So, and maybe on the bolt, I have a washer and I have a nut. Maybe here I have a lock nut in the middle. Okay. So I got 1, 2, 3, 4, 5, 6. 6 parts. Now, if I were to have another bolt right next to it, okay, I can call it again, and this guy will be 1 because it's the same one. You got the 2 bolts. I want to call this guy the washer. I'm going to call it 4. The lock nut, I'm going to call it 5, and the nut, I'm going to call it 6. So you guys will notice that I go and I'm repeating the numbers because it's the same part. So when I go and I want to put my assembly, I'm going to have 1, 2, 3, 4, 5, 6. But my quantity in terms of the nuts, the quantity will be 2 because I need 2 nuts, I need 2 lock washers, and I need 2 washers. I need 2 bolts. I need 1 plate top, and I need 1 bottom plate. I will have to create a drawing of anything that it is not that I will not go and buy. For example, the bolts and the nuts, I can go and buy them in any hardware store. That one most likely I will not have to manufacture in my company. I will do only what is required. So in this case, I have 2 plates. Most likely, these are the ones that I'm going to be creating drawings for. So I'm going to call this guy PT001, PT002. And in the description, when I go and I start doing the description here, again, I can also, you can give it a number, but in the description, somewhere there, you got to tell them, MasterCard, okay, or where you buy this material. I hope that makes sense. You only create drawings for the parts that you are doing in your company. Part list. Again, this is a little bit more complex part. It has more things on the inside. You will create as many views and as many sections to be able to convey what's actually inside of it. Remember that you have bubbles. Those bubbles will be calling out to part within your assembly. You will have a part name, you will have a part number, and don't forget your quantity. The good thing about Inventor is that Inventor keeps track of all of this. All you have to do is bubble everything, and Inventor will put a key number, will have a description based on your type properties in the part. I will show you how to modify them. It will know how many of them. It is your duty to go and assign a part number. So if you have a part, you can create a drawing of that part. What do I have here? Cutting planes in assembled drawings. Yes. So what about if you have a bolt? Right? You have a bolt or any type of cylindrical feature like the one that is here. If I were to create a section, I want to be able to see to the bolt. Try to make drawings a little bit nicer. If we were to have a bolt, something like this, and that guy goes there, somewhere here. I want to know that I have a bolt. If I were to cut it somewhere in there, right? Cut and look through it, cut it somewhere in the middle. I want to know that I have the bolt, so I don't want to cut the bolt as well. I want to remove the bolt from the participation when I get the section. I can then also put the plates, but the plates will be part of this section here. Okay, you guys see the plate, that's the plate that is on the top. And the bottom plate, I want to distinguish between the top and the bottom, so I'm going to put a different type of hatching. In fact, it will be at a different angle. Right, now I know that I have 2 bolts. That, and then at this point in time, I can also have my my washer. I can have my lock nut, and I can have my bolt. Right, raise this guy because I also don't want to section it. And then here is the thread of the part. And then you can call out to this guy. You can call out to this guy. You can call out to the nut. You can call out to the bolt. You can call out to the plate. And you can call out to the other plate, right? So much cleaner. Well, every time that you have cylindrical features, and every time that you have different parts that are actually sectioned, there will be a different type of hatching. One different angles on different consistency, right? Maybe this is a factor of 1.0, this guy is a factor of 0.5. something that will make it different. So that's why you guys will see here a part, everything that has the same sequence, like this hatch, that pretty much represents a single part. So this guy is just that has a hatch, but it's a breakout section, so it doesn't cut through the whole part. So you just gotta follow the similar hatch, and that will be representing one part. We do not section. What do I write there? What did I write there? Computer. We do not section shafts or pins. Yes. Very often we use breakout sections. Yes. But dimensions, if needed for assembly, otherwise do not dimension. You guys will notice here there is kind of like a phantom line. The phantom line represents movement. So what is a phantom line? Phantom line, if you guys want to have something that moves, the phantom line will be line, double dash, bigger line, double dash, bigger line, double dash, bigger line. That is a phantom line. The phantom line represents like a motion. For example, like here you guys will notice this is a front view and it has a little phantom line and it's representing that guy actually move continuously. It represents the same thing here. You guys will use phantom lines, I believe, towards the end of your project, your final project. This is what I was telling you guys about the fasteners. Any type of pins, any type of fasteners, if you have a bolt, you have a nut, you have a rivet, you will not section it. For example, here you have a bolt. This is the correct way of doing it. The correct way of doing it is actually cutting the bolt. So there is a way to take care of the participation when you cut an assembly. It's called part participation. I'll show you when we actually get to do an assembly. Here on the bottom, I have some rivets. Rivets is kind of like a semi-permanent attachment, kind of like a bolt, but you break up the rivet and it pretty much stays consistent. If you have parts that are super thin, like a sheet metal, then you would put a darker hatching to represent difference. And I don't know if you guys can see that view, understand what I'm drawing. Maybe I can draw something here. So what it seems to me, it is that is a hub. If I can draw something, in 3D space. So that guy seems to me, I want to assume here the shape. It seems to me there's kind of like a flange that goes there, and here you have a rivet, and here you have a rivet. So usually the rivets have like a dot on top of it. Then you have the thickness of the plate. Here you have the hole that is hidden, was the whole thing, and then you have a sheet metal component. The sheet metal somewhere there. So the sheet metal is a thin metal, so thin that if you guys were to do a hatching, you will not be able to see the difference. But let's imagine that this guy is thinner, right? Because the sheet metal like 0.06 thickness, so it's super thin. You cannot really see it. So the way they do the hatching, instead of doing like they just make it thick, like dark solid line. And again, the bottom of the rivet. Okay, let's see. Continue. Different sections, different hatches. Yes. If you have different parts within your assembly, each of them should have a different hatch. They are not the same. That's the way you distinguish when you're taking a section. Some of these parts will have a participation, right? Some of them, like a bolt, will not have a participation. The plates most likely will have a participation. Here I have seems to me it is two parts together. If I can draw this in 3D so you understand what you guys are looking at. So it seems to me that you have a part that looks like this. And then you also have a key, and then you guys also have something that actually this one doesn't have that. Here, with my the fastest I can draw this so you guys can see what I'm looking at. Boop, 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 boop. Something like that. And then that pin will continue as well, right? And then you have a shaft that will go inside. So this, boop, boop, boop. Again, they don't have the correct lengths, but this is the top, this is the top, this is the bottom, this is the square shaft, and this is the key, right? So you go and you put this one on top of that one, you put the shaft on the inside, so it's going to slide, and then you put that key in the middle. So that's why you will notice that this guy, that guy, that guy. So there are 4 parts separate, so each of them should have its own catching once you actually assemble things together. Here you have parts that it seems to me they have actually a thread. And we usually will not do this type of thread. We won't do the little zigzag thread representation. We are going to be a simplified thread representation. So simplify means I'm not going to, if I want to have a bolt, I'm not going to say the bolt and I'm going to put a little zigzag like this, right? So I won't do this. If I want to have a bolt, I will continue it like this, and then we'll make this guy hidden. That's the simplify. This is the way we're going to do it. We are not going to do it like it's shown here. Let's move into a different one. Okay, so for assembly drawings, you have different parts. You might have sub-assemblies as well inside of it. Each of the parts in each of these sub-assemblies will be in a part list. Each of the parts that you show in the assembly will have a bubble. The dimensions that you get to put in that assembly are only going to be for assembly conditions, instruction for the people that assemble things together. If you give it other dimensions, they should be as a reference dimension. When you go and you cut into this section, into this assembly to see other parts, because they are internal parts, you are not supposed to have participation in the section for these bolts. You're not supposed to section the bolts or the washers or the nuts. The type of threads that we are going to do here are going to be simplified thread representation. Okay, so that's the general assembly drawing. Let's look into a different assembly. This one, it is the detail assembly drawing. So this type of assembly usually is pretty common in the consulting section. When you go and I remember when I used to be a structural drafter, I used to do this type of assemblies all the time. Not necessarily have a part list. We had callouts on the drawing in themselves. So let's think about like this detail assembly drawings when you have the parts and you have the dimensions, and if you have welds or you have something else that is going to assemble, you get to put everything in there. So back in the day, I'm going to assume that it used to be the most common way because you didn't have to create so many drawings because everything was already given in one drawing. Not necessarily too often now, because now it's so easy to make a drawing after you create a model. So the CAD world, now you will have a part and an assembly. So you guys will create a bunch of parts and then you will assemble them. So for each drawing, there will be a part, and then you will have one drawing for the assembly. So one drawing assembly, and for each of the parts within the assembly, individual drawings. Nowadays, each part drawing and or model is stored in a file identified by the part number, and the assembly is stored in a file identified by assembly number. Let's read the description and use of the detail assembly drawing. The detail assembly drawing shows the assembled relationship or items, one or more, which is detailed on the assembly drawing. Separate engineering drawings are not required for items so delineated, particularly useful for inseparable assemblies. Like again, if you guys were to have a detail assembly, for example, I'm gonna make the same assembly that I showed you before. So for example, let's suppose that I have this assembly with two plates. One that looks like this, something that looks like that. Okay. Well, if I want to create a detail assembly of this guy, when I want to start here, I want to come up with my front view, and let's say that I want to go and I want to do the side view, something like that. Right. You can also come on isometric view if you want, but they didn't do that because it was more work. So you come over there and you say, okay, so I need to make sure that I got this guy, and I also might want to give them the overall size. So these are actually dimensions, okay? Because you're doing everything here. You might also want to give them this guy. You might also want to give them this guy, and so forth, right? So you give all the dimensions they want. You put a bubble. You put a bubble. You have balls, so you have a weld. You also pull out the weld, right? If you go to the other side, you want to put the different dimensions that you need. Maybe you want to give it the overall width. Maybe you want to also give it that height. Actually, not this one. Maybe you want to give it this guy as a reference dimension. So it's kind of like creating a drawing, but with all the parts put together, and when assembled information, how to put things assembled together. So it includes necessary information for procurement, fabrication, and inspection of the details and assembly. Show items which require extensive machining operations on a separate mono detail drawing. Parts may be detailed in the assembled conditions or as a separate detail on the drawing. Clarity for fabrication should be the prime consideration. Meet all requirements of a mono detail drawing in an inseparable assembly drawing. So you just give it all the information they need to put it together, pretty much. That is the detail assembly drawing. Let's take a look at one of them. Working drawing assembly. So here you guys will see a mess. This is a detail assembly. So again, it contains a bunch of dimensions, contains a bunch of details of what each of the things are. So washers, I don't know if it has any weldings in here, but commonly we also have welds. This one is a single part. This has like a washer. So a bunch of information, everything included into one. So way too many things going on, many dimensions on the detail. And it also has seems to be also a part list. So similar like the general assembly in terms of the part list, but with all the information required within the same drawing. You don't go somewhere else and try to do it. Unless it's something that is super complex, you will have a mono detail, a detail on the side that has all this information. Okay, let's wrap up with the welding assembly, and then we will continue next week. Let's do that. Okay, computer. Welder assembly. So welder assembly is when you weld things together. See, you put the parts. You put the part. Detail assembly drawings like the one above actually and separable assembly since the parts are welded. Might possibly be given to a welder fabricator in a maintenance department or a small production shop. The same person would cut the parts and weld them together. But in most manufacturing operations, different groups of workers make the part and assemble them. The workers who make the parts need clear part drawings. The workers who assemble the parts need assembly drawings to show how the parts get together, and a separate parts drawing to help identify the parts. So let me actually try to make kind of in a company what would be the scheme. So you have your design department. You have your inspection department. You have a fabrication department. Within your fabrication department, maybe you will have your machining department. You might have your welding department. You might also have a electrical, and all people that make hydraulics and so on. It's kind of like creating an assembly line to make things easier, right? So the design will come up with an assembly drawings, right? And it will have 20 million parts, right? The inspection will go to the part drawings, and it will go to whatever that is the when the fabrication came up about, and it will bring in each of the parts, and he will inspect them and say, okay, it's good, it's not good, it's good, it's not good. Okay. The assembly drawings and the part drawings are also going to go to the fabrication. Okay, and the fabrication will go and say, okay, now this has to be machined, this has to be welded, this guy has to have some type of electrical system. Okay. So this guy has to communicate with inspection because you got to put everything in written media. So the inspection will look at the drawings and will be able to communicate the design intent. The fabrication also looks at the drawings to be able to communicate the design intent. So it is important that you have a good. That's why you actually follow the company requirements, because depending on the size of your company, it might be different. If you have a small shop, maybe the only thing that you require is something like this. Okay? I'm gonna stop it there. Stop share. And stop. Good morning, engineering 2. Can you guys hear me? Yes, there we go. Let me start the class by sharing my screen, and then we can talk about what we are going to cover today. So, let me bring up these lectures. Yep. Okay, so what we're going to do today is we are going to talk about assembly drawings. Let's wrap up the lecture of assemblies, and then we can actually begin our first assembly. Okay, so during the last time we met, we introduced you guys to assemblies, and we said that they are high-level assemblies. They are subordinate assemblies. So if I can regroup what we talk about, let's see that's in mind. We said that they are. Let's make a car. We have a high-level assembly. We have a subordinate assembly or a low-level assembly, and you can also have parts. Let's put a part. Let's just put a tire. Okay. So every time that you have a high-level assembly, that means it encompasses everything. So all of this is a high-level assembly. Within the subordinate assembly or low-level assembly, you can also have parts. You will have its own little drawing from the subordinate assembly. Let's say this is the motor. I guess within the motor, you can also have parts, or you can even have subordinate assemblies within a subordinate assembly. Level of detail. We also talk about the bubbles. We said that the bubbles are like the identifiers of each of the parts. You will have a part list. The part list most likely will have your bubble. Will tell you the number of items. It will tell you a little description. It will tell you the material. It might tell you if you're going to buy it or you're actually going to have a drawing. If you have a part number, that means that you have to create a drawing for it. That's something that gets manufactured within your company. There are not really any set standards for assemblies. So we are kind of going over the main things that have in common. Last time we talked about general assembly drawings, which is the ones that don't have any of these dimensions. Any type of dimension that you have are because they're going to be part of the assembly condition. How do you put it together? We also talk about the detailed assembly drawings. The detailed assembly drawings are the ones that have everything, including the dimensions. Back in the day, things were done this way. Certain, let's call it, consulting firms still do this. There are somebody else that actually do. So let's write that down. There are certain consulting firms that do these assemblies. Let's call it this detailed assembly. All right, assembly, and they send this out, and somebody else actually comes up and creates these fabrication drawings. And again, the fabrication drawings are actually another type of assemblies. So everybody where you work, or everybody that does this, most likely will have their own little standards. That is not a base standard. Everybody will have different information. The consulting firm will take care of their aspect. Will send out to somebody else to come up with fabrication drawings, and then we'll come up with real models like parts and drawings and stuff to put it together, right? Okay. This is a detailed assembly drawing. We talk about it. We also said you might have inseparable assemblies, also sometimes called welded assemblies. The welded assemblies will have information to put things together. What's the type of weld? So, and again, I believe we will have our own little lecture on welding. So let me see, welded assemblies. So, for example, right here, you guys will notice a couple of dimensions. All right, and it has a couple of symbols. This guy here, the symbols are here, and that symbol, this one right here, this one right there, and oops, so that doesn't let me. But the one that's on the bottom and this guy is also welded. That's a welding symbol. It's very much telling the welder what you're supposed to do. It seems to me that this is a detailed drawing because it has all these dimensions within the drawing. It's not something that we do often now. Most likely you will have each part, each drawing will have its own thing. Again, it really depends on where you work, right? When I used to work in the structural engineering / consulting firm, we used to create detailed welded assemblies all the time because somebody else came up with fabrication drawings. They will actually separate it and we'll have kind of like similar callouts, but more in terms of how the fabricator will use these drawings. The detailed assembly drawing, like the one above, actually is an inseparable assembly. Like it's welded, so you cannot separate it. Since the parts are welded, might possibly be given to a welder or fabricator in a maintenance department or a small production shop. The same person would cut the parts and weld them together. But in most manufacturing operations, different groups of workers make the parts and assemble them. The workers who make the parts need clear parts drawings. The workers who assemble the parts need assembly drawings to show how the parts fit together. So in other words, if you have a small shop, you can actually go and give them something like this. If there is a big project, most likely there's going to be some third party that will take it. Like for example, in my case, when I used to work as a consultant, we used to have drawings sent out like this without even the bubbles. We didn't have bubbles. We just had notes. And then somebody else will make up the fabrication drawings, and then they will get to be fabricated, right? They will go to the let's call it to the machine shop department, and then we'll go to the welding department. So different departments that will take it. Again, depends on how big is your shop that you're working. You might have to go to third parties to actually get to do the stuff, or if it's something small, you can handle it within a small production shop, right? Making an assembly drawing. What do I have? Making the assembly drawing. I don't know why I have computer. Well, when you make an assembly drawing, remember that the main priority of the assemblies is to convey design intent, right? And the design intent for assembly is to assemble, right? So you can have sectioning, but the sectioning are going to be maybe when you have things internally that you want to show them, say, hey, there is something going on, like a bolt, like a washer, like a nut. Maybe there is some type of feature that you want to, because they assemble together, you want to be able to represent them. You're going to have the views, again, the showing necessary information to be able to assemble things. You can have full sections, you can have half sections, you can have breakout sections. The hidden lines, that are usually omitted, as they can have a lot of confusion. Just keep in mind that you have a lot of things that are assembled together. And then if you put hidden lines, they're going to be hidden lines from the part plus all the other parts that are assembled together. So usually the hidden lines are omitted. Dimension is you only put dimensions to indicate functional relationship in terms of assembly. How do you things fit together, right? So every time that you think about an assembly, think how to put things together. You are putting things together. Every dimension that is there is not really to come up with a part drawing, but to assemble that part once you created the part. Let me see. This guy is a different type of assembly. This is called the outline assemble drawing. So let me see, outline assemble. I think the outline is the one that you go in when you buy a motor or a pump, or this one, it seems to me this guy's a motor, and you really don't want to know anything about what's internally. Maybe you just, maybe what you have, let me make a motor here. Maybe what you have is a motor that looks like this, and you are going to put it somewhere else. Maybe this motor will be here. And it's gonna be part of a high level assembly, right? Maybe here you have hoses, and here you have something else going on, right? More equipment and so forth. And the only thing that you worry about it is where this motor is going to be in relationship with your high level assembly. You're gonna buy the motor, and you are going to use it in high level assembly. So what would you want to know? Well, you might want to know the overall size. You might want to know the overall size. You might want to know what is the attachment points, right? Where the bolts are going to go, so it could be embedded or bolted into your assembly. You might want to know the shaft. You might want to know its diameter. You might want to know its length. You might want to know the revolution per minute. You might want to know the voltage input and the what is the horsepower. Horsepower, right? So you will get all this information, right? What is relevant to your motor. But at the end of the day, I don't care what's inside, because I'm going to buy it and then I'm going to mount it. So the outline assembly drawings are illustrated for in purposes in catalogs. So you guys will notice here, those catalogs, most likely they will come up with a letter. So you see a letter P, letter O, letter D. So it's information for you that you're going to put it in a high level or an assembly. The only thing that you guys will want to use is certain dimensions. For example, here I got P. You will look into P. What is P? Right? I don't know. You will look for the letter. So you will look for the letter, and you guys will notice that there are different models. So I got 203 and 204. And the reason why they do this is because most likely they manufacture models like crazy, right? And if they will have to come up with a drawing for every model, it will be too much time consuming. So they say, you know what? I'm going to call this letter A, and I'm going to call out that letter B. Maybe this dimension, this spacing from here, I'm going to call it letter C, and so forth. And then they just put it on the table. So in this case, outline used in catalogs. If I'm buying a motor, I do not care what is going inside. I just need the overall dimensions and the power so I can use it. Do I have an example of it? Seems to me I have an example here. Outline assembly example. Come on, computer. I think I'm not using this blue beam to do Zoom lectures. Seems to me it doesn't like the Zoom lectures. Here an example. Keep in mind that it's giving you, okay, so it seems to me that this one, it is an outline assembly drawing, but it's giving you the dimensions directly. An outline assembly showing the general relationship of the parts of the assembly and the overall dimensions. No sections of the or part list. I'm not putting it together. I just want to know what is the overall size, how to fit it in the rest of my equipment that is in my plan. How am I going to use it, right? This guy is going to be part of a high-level assembly. How am I going to use it? Okay, general assemblies, the one that we covered first. Actually, make a little summary. Okay. So we got general. We got general. So this one we have parts with bubbles and dimension for assembly, and also a bill of materials. Sometimes they also call it parts. Okay, and each of the parts will have its own drawing, right? Then you have the detail assembly. So detail assembly, everything in one drawing, or try to keep it in one drawing. You have all dimensions, all the sizes, everything's already there. You also have your outline, and the outline assembly. This is kind of like for a catalog, right? And the catalog means overall means only. That's it. That means no bubbles. That means no detail inside of the part. All I needed is for to use it somewhere else, right? That's my outline. Inseparable assembly is a welded assembly. So if I come over here, inseparable, this is welded. So, and again, it's detail for assembly. Detail for assembly in terms of welding. How you want to give it to somebody to weld it? What will be the dimensions to be able to weld it? You have installation assembly drawings. That's the one that is kind of exploded view. And the pretty much telling you how to install it. That's all it is. List of items to be installed, locating dimensions and associated tolerances, types of quantities of attachment, process of special installation requirements, adjustment data, the special test or inspection requirements, detailed definition of the special installation parts. So how would you install it? Okay, you guys will notice that it has the parts. You can also have an exploded installation assembly. So this guy here has a bunch of bubbles. We might talk about how to create one of these ones. Usually, this type of assemblies will use for the maintenance department. In case that you guys want to fix a part, you will come over here or how to put it together as well. You say, okay, so I need this part. This I got broken. Look at the number, and then you will order it, right? And then you will be able to put it all together. Let's talk about welded assemblies. It's pretty much when you guys see everything that you put in there. Well, if you have a weld, you will need to put a weld, right? This is the color for the weld. And every dimension that you put in there, for example, this plate is going to have its own drawing. And it's because it's going to have its own drawing. I don't need to, if I give him a dimension, I have to give it for the mass reference. I'm not dimensioning the part. If I'm putting a dimension, I got to give it to them as reference because that's why they have their own drawing with its own notes. They have, unless otherwise specified, use the type of tolerance. So I don't want to have calling different, the same dimension in different places. Now, all the dimensions that you guys will see here, like this 0.63, this 1.75, are meant to be for assembly conditions. For example, I'm telling you this plate that is right here is going to be located from this side at 5/8 of an inch. And this 1.75 is telling you after you assemble both of them together, the bottom plate and the top plate, the overall size is going to be 1.75. And because I know that somebody's going to be welding, you got to give them a tolerance, but the tolerance has to be a little bit more, not as tight as you would do for this other plate. So let's say plus minus a 16 of an inch. And then again, you got to call out the weld. We will talk about welds not too long from now. It is time for us to create our first assembly. Let me come over here and start working on this. So I'm going to go to your homeworks. If you guys go to your homework, you guys will notice that you have in-class assignment and a homework 17. So I'm going to create a new folder and I'm going to call it homework 17. Homework 17. And within the homework 17, let's focus on the in-class assignment. And it has a bunch of parts. Let me copy them all. So you will do something like this. I would suggest you guys create two folders. One folder for the extra credit and one folder for the homework 17. So again, I'm working on the homework 17. I have my inventor open. So let me open all of these parts and then we can talk about it. So open. I think I have them here. Come on. This is what we aim to put together, right? These two dimensions, these views right here. Okay, and because I don't really have the time to actually go and create each of the parts. What I've done, and I created the parts for you. We are just going to put them together. Okay, so here we have a couple of parts. I got a collar, I have a base plate, I had a bearing, and I have a cap screw. How do I create an assembly drawing? Well, you come over here where you have the sheet type of deal, and you're gonna click on new, and it will come up with something that looks like this. And here where you have a standard assembly, you gotta click on the standard assembly, and you just click create, and it will create an assembly. The assembly is going to have also a model tree or a browser type of deal. This is a model tree. It should also have a origin. So you come over here and open that folder. you can click on the first one, hover down and click shift and hold it, and then click on the last one, right click and click on visibility. So that is the origin of the part, origin of the part, right? I mean, origin of the assembly. How do I put things together? Well, the first thing that I want to bring in is the base plate. So you want to bring in the part that is not going to move first. So in my case, I want to use this plate as a part that is not going to move, so I can constrain other parts to it. So let's bring the base plate. So how do I do it? I right click everything, left click, right click. So I'm going to say place component. And then I'm going to be looking for the part. And again, I think all of these, I have it on my desktop. So I create a folder. Let's see. Engineering to inventor, almost 17. Is the base plate. So you find it, and then you say open. You say yes. You say yes. In my case, is because I did not change my project. Maybe I should do that first. Huh? Let me close this guy. Close this guy. So, how do I create a project? I think I should be able to create a project here. File, new. Let's have a project here. I know that the project you can create it from the start of the page, but I don't want to start again. Okay, in you guys' case, don't worry about it. It should be your default project. I created a project. I will talk about it in the class. These are the projects, right? Or you know what? Maybe I can open the project directly. Desktop, in the desktop, and then look for engineering 2, and I should have a project for files right there and open. And that doesn't like it because I got all these files open. Okay, we'll talk about projects. Don't worry about it. You guys don't really have to worry about projects. If you guys remind me during lab, I can explain about the projects. Right now, I don't really have the time, but in the lab, I will have the time. I'm going to create an assembly, and then I am going to turn on the origins, use the same way that I did it before. Turn on the visibility. I am going to right click and place a component, and if you guys recall, I was looking for my desktop where I created my folders and I copied everything. And it is homework 17. It is the base plate, and it's going to scream at me, and you just say yes, 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 yes. Before I click on anything, I gotta click it and make sure that this guy goes and uses the same origin. So this part has its own planes and axes and everything. I want them to use the same origin than my assembly. So the way I do it is I right click and I say place grounded at origin, and it will ground it. See it? And then we want to ask you to place another one, so you just type escape. And now if you want to move this plate, you guys will notice that it will not move. And I use the same origin. You guys can see here, right? It's the same origin than this assembly, right? So what I'm going to do instead, I'm going to hide the assembly origins, and I'm going to turn on the parts origins. Okay. Remember, the part has its own origin and own axes, and the assembly has its own origin and own axes. When I brought the first part, I use the same. I lock it in origin to origin. So now I cannot move it. It's not movable. Okay, let's bring the next thing. The next thing that I want to bring, it seems to me, is the bearing, the flange bearing that's on the top. So flange bearing, how do I bring it? Right click, place component, and it's going to eventually go find it, and that's the problem because I don't have the project, so it's going to ask me to do it every time. Maybe I should have done it first from the beginning. It's okay. The next part is the bearing. So you look for it, and then again I'm going to open it, and it's going to scream at me, and you just say yes. At this point in time, you just click somewhere else, and you can, if you click again on the screen, it will try to create different copies. I just want to click on it once. Now I want to constrain this part. You guys will notice it's all over the place. Constrain this part, so it constrains on this plate. How do you constrain it? Well, I can right click, and I can click on constraint. Once I click on the constraint, it's going to ask me for mating parts. So, if you put a side with a side, you can put them. One part will have a face, and the other one will have a face. You can mate them with each other. So, for example, in my case, I have this face. And you guys will see an arrow. That arrow, I don't know if you guys can see this little arrow. It is looking for another face. So, I'm going to look for shift middle mouse button to rotate and choose the other face. And you guys will notice that it has an arrow. I don't know if you guys saw it, but it put the two arrows kind of like bypassing each other. And I say apply and escape. Now, if you guys were to look at a side view, look at the side view, That guy now lives in that plane. In that plane, actually, I cannot separate it, right? So I constrain that degree of freedom. Uh, what else do I want to do? I have an axis here, and I have another axis there. So I want to most likely use the axis. So I'm going to right click, and I'm going to constrain. And again, I'm still using the mate, but now I'm going to be mating the axes. So I'm going to look for an axis right there. That's an axis, and that also an axis. And you just look for, you gotta look for the axis, that one, right? And then it's going to ask you, hey, you need another axis. So I'm going to be looking for the other axis, and boom, it shows in only little ways of putting it together. I'm going to say apply. And now, if I were to grab my bearing and rotate it, see how completely constrained. Okay. Now, what I want to do is I want to use this axis and the axis from that other hole and constrain it. So I'm going to say right click constraint. I'm going to be looking for the axis, so you got to find it right there, click on it. And then you got to look for the other one. Again, you just kind of hover till you see that line that is dotted, and that is the axis. And then we'll put it align. I will say apply, escape, and now if you want to move it, that thing ain't going nowhere. Okay, let's continue assembling things. So I got in that bearing. The next thing that I have is the collar that is right on top of it. So how do I bring the collar? Well, right click, place component. Everything left click, right click. Place component, and again, I'm going to have to go to my nightmare of finding this, which I think I put it on engineering to inventor, almost 17, and we're looking for a collar. I'm going to say open, it's going to scream at me, and I'm going to say, okay, let's put it somewhere there. Okay, so now I need to insert this guy into there. So there is another way, instead of me putting a bunch of faces to faces and axis to axis, there is a shortcut, and that is the constraint, which I believe is called insert. So this one, insert, is going to ask you to look for two cylindrical parts that you want to mate together. So for example, the one that I want to mate, I want to look at that edge. If you guys could see, let me change the view so you guys could see the edges a little better. So I want to change, shade it with edges. There we go. See that edge? It's the one that I want. So constraint, I want insert. I'm looking for that edge, and I'm looking for this edge. See, and we'll try to put it together, like kind of inserting it. I don't know if you guys saw it, but I'm actually repeating. So again, I'm trying to put two edges together, kind of like inserted right next to each other. So here I chose this guy, and then I chose that guy. So put both of them together, kind of like aligns those two edges together, and it puts it all into one. So it created the mate, and it created the come over here. It created the insert. So the axis aligning and the mate to the part all at once. What else do I have? I'm not sure if I did this correctly. I think I did. It's pretty good. If you are you're not really sure if you did it right, you can always do a half section. Go to the view tab, go to the half section, click on one of these planes, and it will chop it in half, and then you can look if you actually did it right. So it seems to me that I did not do it right. It is colliding. So how do you get rid of this constraint? You just go here to the browser, find it, and then delete the constraint. So this guy should have been a little bit higher, something like this. So that tells me that I did it wrong. So instead of using the mate that I did, I'm going to end of the section. I'm going to be using the whole instead. So let me see constraint. I'm going to go to the insert. I need to look for something that's going to mate with each other. So in my case, I'm going to use that guy and then this guy, and it should work. Cool. See, kind of like look weird the last time, but now it looks pretty good. Again, you can also double check. Come over here to the section, do a half section, click on this guy, and it looks pretty good. And we'll call it good. We'll call it it. Let's come back. Let me see what else do I need to do. It seems to me that I have a couple of bolts. They are 3/8, 24 UNF 2/8 with a cap screw, flat head cap screw. Okay, I give you the bolts, so I'm going to say place a component. I'm going to grab that component, which I believe, again, I'm going to go to the nightmare to find this guy, my desktop. I am going to look for inventor 17, and we are looking for cap screw. I'm going to say open, and again, it's going to screen at me, which is okay. I'm going to place one, and I'm going to be using my cheat insert command. So I'm going to constrain it, right click constrain, go to the insert, and again, I'm looking for two things to align with each other. So I'm going to choose that guy, and I'm going to choose the edge of the bolt to align it together. Boom, and I'm going to say apply. And I also want to constrain the rotation of my bolt, because my bolt, if I want to rotate, you see it rotates. So I need to put an angle. So if I go here, you guys will notice that my bolt, the flat head, it is aligned to my axis. So I am going to try to constrain it, but now I'm going to be using an angular constraint. So the angular constraint is right next to it. It has an angle. I'm going to use the direct angle, and I'm going to click on this guy. Let's look at plane, that one. And then I'm going to look at the other plane. Look for the plane right there, that one. And I should create angle with angle, 90 degrees with each other, 0 degrees from each other. And I will put it right, I will lock the degree, right? So right now it's kind of like rotating 360, and then look from something to relate it from at 0 degrees, and I put it in line. So now I cannot move it, this is completely locked, all the degrees of freedom. I can also grab another cap screw and drag it. So I'm going to grab it and put it there. And again, if you guys you're interested in see the degrees of freedom, you go to the view, you have a degree of freedom right there. Oh, you see it? So it can move up to the right, in and out the page, and it can rotate on each of its axes. So now if I go and I put my my constraint, and I use my insert command, you guys will see how some of these degrees of freedom disappear. So I use that line, apply. And I don't know if you guys could see it, but there is 1 degree of freedom right there. You guys can see it. Not like a circular part. It's telling you, hey, that's the one that you're missing, right? Which is kind of like a rotation about the axis. So I can always constrain it by using my angular constraint, the same way that I did it before. Constraint, and I want to say that I want that guy and this guy, and at 0 degrees, I want to say apply. Boom. Okay. All right. So how do you place a part? Again, the first part that you put, it should have a base to origin. That should always be locked. And then after you put the next components, how do you place a component? You just place it, right click place, look for it. And then after you place it, you can also constrain it. Once you do a constraint, you are going to have the mate that has two faces together, or 2 axes together. You can have angle, that was a face, when a face, what would be the angle of it. Tangential constraint is when you have things like something that is circular, and then you want to tangential to a surface, or maybe tangential to another circular part. This one is the insert, and then this guy is the mirror. Like if you want to have a plane and you want to make sure that it behaves in a mirror fashion between 2 components and a mid plane. This one is not actually not commonly used, but these other ones we can actually talk about them, right? Let's place this guy on the drawing. I gotta save this first. Let's see, where is this? I gotta put it in my desktop where I have all my mess. I'm gonna put it homework 17, and let's call it homework 17 extra credit. Oh, yes. The file format for an assembly is called the IAM. You guys see here the ends IAM, that's an assembly. The IPT is the drawing, the part, and the IDW is the drawing. Let's put this on a drawing. We have a drawing over here. I'm gonna have to get me a template for a drawing. So I'm gonna go here to the homeworks, and let me look for a B size. You can find one. US border template, and let me get a B size. Now, when you guys are submitting your drawing, do not forget to submit all of your IPTs, all of them, your IDW. Now you also will have your IAM, which is your assembly, and your IDW, which is your drawing, and your IPT. So there is four files now instead of 2 files. So a little more complex. Now you have an extra file to submit. And you have multiple parts because it's not only one part. Okay, let's place things in the drawing. How do I place something in the drawing? So first you go to your assembly, then you go to the drawing. Make sure you have the assembly open. So we'll find it, right click, and you base the view. I believe, let me see, what is the scale that I gave you? It is a 3/4 scale, and I have a front, an isometric, and a section view. So let's do that. Let's do the top, like that. And I say it is a 3/4. So let's place it there. I want to say okay. And notice there is no hidden lines, but we don't want hidden lines. I'm going to do another base view. That is going to be my isometric view. And again, I also wanted 3/4. I'm gonna say okay. I'm gonna move this guy somewhere here. The next thing that I want is I want to have a section of this. So section, I'm gonna select the view, which is this one. I want to cover to something that is cylindrical, something that splits the view in two. Then I'm gonna come over here, click, right click, and continue. And then I just gotta go down, fill this guy in lines, and I'm gonna say okay. That will create my view. Everything that you have something symmetrical, you don't necessarily need these guys. So how do you get it off? You go to the annotate. You should have some layers, and you're looking for the section line. Do not turn it off, and I will get rid of it. If I don't want my callout, I double click on my window, and I click on the light bulb. Say okay. Boom. I have a couple of parts. These bolts, you guys see, just like mine, my bolts do not look the same. My bolts should be excluded from the participation, from the section participation. How do I get rid of it? Well, first of all, if I were to click on it, you guys will notice that it selects the line. So I need to change the way I select things. So right now I have edge priority. I need to change it to part priority. So it's a part priority. I'm going to select it. I'm going to right click. I'm going to go to section participation. And I say, you know what? I don't want it to participate. Boom, I will take it off the participation. I want to do the same concept with this guy, participation, and I don't want it to participate. Also, you guys will notice that I have the simplified thread representation. See if I can zoom in so you guys can see it. So, simplified thread representation is kind of like a couple of dash lines. I don't know, resolution is pretty bad. The way you show the simplified thread representation is by clicking on the view, double clicking on the view until this guy comes about. Go to the displays option, and you should have one that says thread features. So say display the thread features, which are the lines, and it should bring them right there, right? Thread representation. Okay, I'm going to assume that you guys can put the dimensions. And again, I already explained you this 7 inches that is there. It's given to do as a reference because what if I were to do actually this, you will have to come up with the part, and the drawing will have the dimension and the tolerance. So this guy is just for reference. Okay, what about the bubbles? How do I put the bubbles? How do I put this list? Right, you have a list on the bubbles, and I want to list. So the bubbles, the way you do it is you come over here and remember left click, right click, and one of the bubbles is the balloon. So I'm going to click on the balloon, select my part, and it's going to come up with something that tells you the bill of materials properties. How am I going to do this? I usually like to do a structured legacy, which is kind of like the way that used to be done back in the day. Right? And then I'm going to click OK, and it should create a balloon. So I click and then I make a line horizontal. When I'm done, I right click and I say continue. It seems to be like here I got another one. I got the bearings at the come, click and click, make sure everything looks aligned. And then again, I can always come over here, click and click, and I do a line. And I can also put the bolt. So over here, click and click, and you say okay, right? So it went and I detected each of these parts and I give it a number. Let me move this note somewhere over here. And let's create the bill of materials. How do I create the bill of materials? So if you guys go to the annotate tab, you should have one that says part list. Click on the part list. And it's going to ask you to select the view. Well, this is my view where I put it on my balloons. I'm going to say okay. And then I'm going to say okay. And it should put a bill of materials, right? Something like this. And you guys will notice that I created your items, right? 1, 2, 3, 4. There are 4 balloons, 4 items, and it knew how many you use. For example, the bottom one was 2 bolts. So a new and I put the quantity of 2 because you put it in the assembly. Okay, so now in terms of the description, you guys will notice that it has a part number, description, material, quantity, and file name. So let's grab this guy. Part number, description, material, quantity, and file name. So how do I do this? So if I click on it, actually double click on it, you should have something that looks like this. And if you go to the left side, you should have one that says column chooser. So these are the things that you can put in your table. So I got item, quantity, and I believe it was item, part number. So we're going to put the part number first. I'm going to grab it and I'm going to push it up. Then right after that, I got the description, material, quantity. So that description, then material. Where's material? I'm going to find it. Material right there. I'm going to put the add. material quantity, and I think I also have the file name somewhere in there. File name. So the file name, again, the same concept, is gotta find it. File name, and you just add it, and now it has everything that you want. You say okay, and then you say okay, and then we'll put it. You want to move your table, clean it up. So I'm gonna move it, clean it up slightly there. Move the columns so they look better. Boop, boop, boop. Boop, boop. And again, you can always change the arrangement. What about the part number, description, all this? What is it? What about if I want to change it? Well, you can change it by double click on it and then just type it. Literally, you can just type it. So say chicken, right? Chicken. And as soon as you type it, it will turn blue because you overrode it, but it should update here. Or you can open any of these parts, and all of these part number and description, everything should be in your properties of the parts. So for example, you open the bolt, and you come over here on the cap screw and right click on it, you have these properties. So I properties, and it tells you everything about it, right? So for example, what's the name of your, let's see which one is here, right? Part number. So again, I can call it chicken part number, chicken. You should also have something, all of this information that is there. I don't know if you remember that you have a column chooser. All of this one you can actually put in the table. You have a status. Seems to me that you can have who design it. And also it gives you the physical properties based on the material that you choose. This is the density, this is the center of gravity, how much it weighs, what is the surface area, what is the volume, and so forth, right? Now, if I save this, remember I call it chicken when I go into my drawing. I don't know, part number, I don't know if I went and I don't think it updated. Let's go over here. BSCA is part number. Let's double check again. Make sure it changed. I don't know if I updated part number right there. Need to call it chicken. And you can update this in the part, and then it should update in the drawing. Let me save it. Let's come over here. And now you see a chicken, right? So it is just a matter of you going to the part and changing the properties, and then this table could also be updated. Okay. The material, you can also override it. You can change the material, the way you choose material. You just come over here where it has the material, and you can choose different materials. So material, cast iron, titanium, and again, remember, because it has the properties, and we'll find out its weight. Okay, pretty good. Let me see. What else do you guys need here? Can you guys do dimensions? Yes. Can you guys do bubbles? Yes, I show you how to do bubbles. Can you finish this note on the bottom? How much it weighs? Yep. Can you do the table? Yes. Okay, so I think I'm done with the lecture. And we can actually talk about the assignment during lab time. Let's stop.